so here we want to prove this equation here, which is a theorem of Euler. Alright, so let's have a look at each of the segments here that we know that it did give us a hint. It said start off by letting AB vector equal B. Actually, I'll just put it on here, pretend I've written it. So that's going to be vector B. Let AC be vector C, AD be vector D. So we've got the B, C, and D there. Okay, so start with that. Actually, you can't see it on my picture because it's so bad. So I'll just write it here as well. AD being D. If that's the case, let's start with this left-hand side. What is AB? I'm not going to have room for all this. Let's see how we go. AB squared, so, sorry, AB, and that's what we want, squared. That's what it's asking for. So it's the distance from A to B, all squared, or the interval AB, all squared, which is in vectors, is the vector AB, the magnitude of it, squared. And we know AB is vector B, so this would be B dot B. Okay, let's do the same thing for each of these. So let's go for BC. So BC, vector BC squared. Now we don't have B to C, but in order to get B to C, let's go B to A, which would be negative B, right? And then A to C, which is C. Okay, let's do that. So we know it's going to be C minus B, dotted with C minus B. So if I do that, so I wonder if you can hold that in your head, because I'm going to run out of space. So C minus B dotted with C minus B. If we expand that, we know we're going to get C dot C. We're also going to get minus 2BC and B dot B. Oops, B dot B. There. Alright, let's have a look at the next one. Is CD squared. Alright, so again, CD also, C to D, let's go C to A. So that would be minus C, because we're going in that direction. And then A to D, which we've said is D. I'll put the D here. So, to get the square, we're doing the dot of those two. So again, we're going to get a D dot D minus 2 C dot D's plus a C dot C. Alright, so what's the next one? Does it ever end? No. Vector dA all squared. Alright, so dA, well, A to D, that's the same as AD, right? Because this is just magnitude squared, and we know that's just D, so it's D dot D. Okay, so if we've got all those, let's also make sure we've got our right-hand sides ready. So let's maybe do that in another colour, see how we go here. Hopefully we don't need this bit. Okay, so first thing we want to do is have a look at AC squared, so we'll do it in the same way. I might keep going under here. So AC and squared. AC we know is C, so that's our nice easy one. C dot C. BD, running out of room. BD squared is the next one we need. Now B to D, so we could go that way and then that way. So that's our minus, what was that vector? Minus B, isn't it? So a minus B plus a D, or a D minus B. So D minus B dot with D minus B would be D dot D. D's and B's. B, D, and B, B. Yeah, okay, so we've got that one as well. And the last one we need, alright, we need M1, M2. Alright, so if we're going from M1 to M2, let's do this on the side here and then we'll rub it out. So if I'm going from M1 to M2, another way to do that would be instead go around MA, M1A, and then AD, and then DM2, like so. Now, M1 to A, we know that's half of the negative of the AC. The AC was C, but we want the negative, and we only want to go half. So half of C, I'm fairly sure. And then AD is just D, so that's a nice easy one. And then D to M2, well again that's half of what? Half of the negative of the BD. Now we found the BD earlier, which I didn't write down, but that was the square of it. So it was D minus B, wasn't it? In order to get that. So we want half of that one. And we want the negative. That was dB, and we want dB, so we actually want the negative that, so it would be minus d this time. And we want half of it. All right, so we're going to end up with, all right, I'll just write it in here first. All right, so the d's, a whole d, take away half a d, so that's a nice positive. They all look like halves, so I might do that. So that's a positive half d. We've also got a positive half b, but we have a negative half c. So that's what we're going to get for that. Now remember, what we're looking for is the square. So if because we're looking for m1, m2 squared, m1, m2, that vector, all squared. So that's going to be a half times a half is a quarter, and then we've got d plus b plus minus c dotted with d plus c, sorry, minus c dotted with d, b minus c. All right, and we might actually just go for 4 of that, since there is 4 of that, and that gets rid of the quarter. All right, so 4 of that gives us, so we get the d dot d, which is nice. What else do we get? We do get a, I'm going to put all the squares together. We also get a b dot b, don't we, from that one? And we get a c dot c from there. So we get all that, c dot c. Watch me make a mistake here. All right, so we do get those. What else do we get? I might need another colour. We get a d dot b. Do we get any? Yes, and another d dot b. So we get 2 d dot b's. So you could just expand it all out and then collect like terms instead of being silly like me. We also get a negative b dot c and another negative b dot c. Okay, so we get a negative 2 b dot c's. What else do we get? C's and D's. So we get a negative C dot D and a negative C dot D, so negative 2 C dot D's. All right, so now we know all those. Let's see if they fit in this equation. So we'll take the left-hand side, which is all my red stuff. So pretend I write this. Left-hand side equals that. Left-hand side equals that, which equals, and then look at all my red stuff. So I've got b dot b, b dot b. I'm going to collect stuff. I've got a c dot c and a c dot c. So I've got 2 c dot c's, and I've got a b dot, I've got 2 b dot b's. Okay, do I have 2? Yeah, I've got 2 d dot d's as well. 2 d dot d's. And then I've got minus 2 b dot c and minus 2 c dot d. Hopefully I've included all that red stuff. All right, and what I want it to look like, remember, is that side, which is this purple stuff. So you can see the first thing I want is a c dot c. So I might just take out one of those c dot c's and put it here by itself. So in my head, I've taken out that one. So I'll just show you by doing that. And then you can see the next thing I want is all this. So I want a b dot b, a d dot d, and minus a 2b dot d. So I'm just going to write that here. So I want I just put it in another order. B dot b minus 2 b dot d and a d dot d as well. So that already, and then I'm going to have other stuff, of course, so that's coming. So that already gives me the AC, because this is what I'm trying to show, right? AC squared, and it gives me the BD squared. But what happened there? So I used one of those B dot B's, I used one of the D dot D's, and I added in a negative B dot D, which we don't have. So I'm going to counterbalance that with a B dot D. Okay, and see what I've got left. So I've still got the 2's there. I'm going to run out of space. 2 of that. And I've also got one of each of the BB, CC, and DD. So I've got one of each of the BB, CC, and the DD. Now, luckily enough, DD, BB, oops, I don't know why that's doing that. So this is exactly what we've just written here. So that nicely makes up our 4 M1, M2, that squared, which is our right hand side. So yes, it does work. So just do each part separately and then make sure that they do equal each other.